Hello guys, this is Rohit Oze and we will be solving the problem double distances today. Its difficulty level is simple and it just requires observation. It appeared in May Cook-off 2022. So we are given n integers a1, a2 up to an, and we have to determine whether they can be reordered such that each pair of consecutive differences differ by a factor of 2. So we have to find a rearrangement or a permutation of the given integers. Let that new array be B such that for each I between 2 to n minus 1, exactly one of the following two conditions hold. So these are the two conditions, and we also have to note that different conditions can hold at different indices. So let's say A is 5, 3. So our array A is 5, 3, 9 and 11. So now consider this permutation. We can see that the differences are 2, 4 and 2. You can see this is obtained by multiplying it by 2 and this is obtained by multiplying 2 by 2. So we see that there is a possible arrangement of these integers such that the conditions hold. Coming to the input format, the first line of the input will contain a single integer t which denotes the number of test cases. Then the first line of each test case will have an integer n, and then n space separated integers will follow. We have to print a single line. The answer will be yes if it is possible to find a rearrangement that satisfies the given conditions and no otherwise. So n lies between 3 and 10 raised to 5 and ai is maximum 10 raised to 9. If n is less than 10 raised to 5, we will try to come up with a solution with time complexity of n or n log n. N square will exceed time limit. Let's consider the sample test cases. So n is 3 and our array A is 5, 2, 4. Let array B be 2, 4, 5. So these are the indices of the positions. B1 minus B0, this is 4 minus 2, which is 2, and now B2 minus B1 is 5 minus 4 is 1. So we can see that this condition holds. B1 minus B0 is twice of B2 minus B1. So we are able to find a rearrangement. Hence the answer is yes. Consider the second sample test case. We have n5. Let array B let array B 1, 2, 4, 8, 16. These are the indices. This is because 2 minus 1 1, and if we multiply 1 by 2, so 2 into 1 2 will be equal to b2 minus b1, that is 4 minus 2. So we have a condition. Again we have a condition, twice of b2 minus b1 is equal to b3 minus b2. This also satisfies the condition, and hence you can say that we have found one rearrangement which satisfies the conditions. Consider the third sample test case. We can notice that there is no rearrangement possible such that it satisfies all the given conditions. Hence the answer for this is no. Moving to the fourth sample test case, n is 6. (21, 24, and 22). Let array B be 16, 18, 19, 21, 22, 24. So the difference is 18 minus 16 2, 19 minus 18 1, this is 2, this is 1, and this is 2. So we can see this is obtained by dividing it by 2 or multiplying this by 2. Two is obtained from 1 by multiplying 1 by 2. The condition is satisfied here. It is also satisfied here. Again the same. We multiply 1 by 2, and over here also we multiply 1 by 2. So we see that the conditions are satisfied, and hence we are able to find a rearrangement. Therefore the answer is yes. You can see. Let's try to come up with an algorithm for this problem. We are given this array A. Let's say it is A1, A2, A3 up to AN. Now let's assume that we are able to find a rearrangement. Let our array be B. Let's say we are able to find a rearrangement, and now let's try to draw some observations about this array B. So now let's just assume without the loss of generality that B1 is less than or equal to B2. So either one of these conditions should hold. So if B1 is less than or equal to B2, B2 minus B1 is greater than or equal to 0. So this term is greater than or equal to 0, and as it is getting multiplied by 2, which is also positive, this whole term will be greater than or equal to 0. Now this term is equal to B3 minus B2. So which means that this is also greater than or equal to 0. and that implies B3 is greater than equal to B2. And similarly with this, if this is greater than equal to 0, this expression is also greater than equal to 0. As 2 is positive, this should be greater than equal to 0, which implies B3 is greater than equal to B2. We had assumed B1 less than equal to B2, and we saw that B2 is less than equal to B3. Now we apply the same logic for this segment. Either this condition would hold or this condition would hold. As B3 is greater than equal to B2, this term is greater than equal to 0, it is non-negative. Hence this term is also non-negative, which implies B4 is greater than or equal to B3. And if we apply the similar reasoning for this, we get the same thing. So now we have seen that B3 is less than equal to B4. And if we keep on applying the same logic for B3, B4, B5, we will achieve this. So we see that if B1 is less than equal to B2, so this sequence, this array A is in increasingly sorted order. We assumed that B1 is less than equal to B2, and we observed that the elements of array B are in increasing order. If we had assumed this, our result would be the exact opposite, and we would have observed this. So now if there is a rearrangement of the array A, let's say it's P, then the elements should be in increasing order or in decreasing order. Let's consider one of our sample test case. N is 5 and A is 2, 1, 16, 8, 4. We have seen that the elements of array B will be in increasing or in decreasing order, and we also know that B is a permutation of array A. That means B has the same elements as that of A, but they are in just a different order. What we do is we sort our array A in increasing order. It doesn't matter whether we are sorting it in increasing or decreasing order. So we just deal with the increasing sequence in this condition. In this case, our array B is 1, 2, 4, 8, 16. So now what we do is we take the differences . this is 1 and this is 2. So we will go from left to right. We have calculated all the differences. Now let's say we are at this position. We check whether twice of this is equal to this, or we check whether twice of this is equal to this or not. Basically we just check whether which condition holds. So in this case we see 2 into 1 is equal to 2. So we have a condition that holds. So now we move forward. As you can see, we have a condition that holds here. That is, if we multiply 2 by 2, we get 4. So now we move to this position. And now we check for 4 and 8. So we notice that 2 into 4 is 8. As you can see that this array B, it satisfies the conditions for every index I. Hence, this arrangement is a possible arrangement which satisfies the given conditions. Hence, the answer is yes. Consider another example from the sample test cases. N is 5 here and array A is 97, 98, 100, 96 and 88. Consider array B, which is array A in increasingly sorted manner. Let's label the indices. As we saw in our previous example, if all the conditions are satisfied for every index I, then the answer is yes. And if it fails to satisfy even one condition, then the answer will be no. (96 minus 88 is 8). This is 1. This is 1. This is 2. So we can see here, we will start at this position. And we can see 2 into 8 is 16 and 2 into 1 is 2. So neither of the condition holds here. Therefore we will break our loop and we will print the answer no. And we can see that the answer for this arrangement is no. Have a look at the implementation part. We take our input n, we take our input array A. Now we sort the array A in increasing order, and now we run the loop from I equal to 1 till I less than n minus 1, and we check for the two conditions. One of these conditions must hold, and these are the conditions. Either this should hold or this condition should hold. And if one of them holds, we continue, else we print no, and then we break our loop. A loop is from I equal to 1 and till I less than n minus 1 is because we are dealing with ai minus 1 and ai plus 1. So I minus 1 should be greater than equal to 0 and I plus 1 should be less than n. Hence this loop. The time complexity for this algorithm will be n log n. This is because we are sorting the array A and it takes n log n, and the for loop here takes linear time. I hope you understood the solution. Thank you for watching.